Let's talk about how to determine if two lines are parallel, perpendicular, or neither. Specifically, we'll be focusing on lines that are graphed in the coordinate plane, represented by a table or points or an equation. Remember from our previous lesson that parallel lines have the same slope and that perpendicular lines have opposite reciprocal slopes. And that to calculate the slope of a line, if you know 2 points on the line, you can use slope formula, which is y2 minus y1 over x2 minus x1. So for each problem in today's lesson, we're going to be given 2 equations, or graphs, or set of points, or table, 2 different representations of lines, and you have to figure out their slopes. And based on what their slopes are, you will determine if they are parallel, if their slopes are equal, or perpendicular, if their slopes are opposite reciprocals, or neither parallel nor perpendicular if their slopes aren't equal or aren't opposite reciprocals. For line A, it's really easy to identify our slope because it's written in y equals mx plus b, and m is my slope, so the slope of this line is 2. Easy peasy. But the equation for line B is written in standard form instead of slope-intercept form. And I can't tell my slope by looking at standard form. I have to rewrite it to be in slope-intercept form. In other words, I have to solve for y. So I'm going to subtract 4x from both sides. Now keep in mind, these are not like terms, right? One has an x, one doesn't, so you need to leave them separate. So I have negative 2y equals negative 4x plus 10. And then I'll divide everything by negative 2 to get y alone. So I get y equals 2x, because negative 4 divided by negative 2, that gives me a positive 2, and minus 5. Now this minus 5 really doesn't matter at all. That's the y-intercept of this line, but I don't care about the y-intercept. I only care about the slope. And the slope of this line is 2. So since the slope of line A is 2, and the slope of line B is also 2, these slopes are equal. And that would mean that these 2 lines are parallel. Let's try another one. This time we need to use slope formula to calculate the slope of both of these lines. Line C passes between these 2 points, so you can think about this as x1, y1 and x2, y2, and we'll use that information to fill out slope formula. So on the top I have y2 minus y1, negative 11 minus 9, over x2 minus x1, so 3 minus negative 2. Really, that's a plus 2. So simplifying, I have a negative 20 on top, and I have a positive 5 on the bottom, and that would reduce to negative 4. So the slope of line C is negative 4. To determine if line C and D are parallel or perpendicular or neither, I need to figure out the slope of line D as well. Remember that tables give you too much information. You only need 2 points to calculate the slope of a line, and here we have 5 points. So just pick whichever 2 points you want to and plug them into the slope formula. I'm just going to pick the first 2 points in the table. So I have negative 3 minus negative 7, that's y2 minus y1, over x2 minus x1, which is 2 minus 1. So on the top, I have 4, and on the bottom, I have 1. So the slope of line D is 4. So now that we know the slopes of both lines, we need to determine if it means they're parallel, perpendicular, or neither. These 2 slopes are opposite. One's a negative and one's a positive, but they're not reciprocals. They're both just 4. So line C and line D are neither parallel nor perpendicular. Their slopes are only opposites but not reciprocals, which means they just intersect, but not in any kind of a special way. Line E is represented by a table as well, and line F is represented by a graph. So first let's calculate the slope of line E using slope formula. Again, I'm just going to pick the first 2 points in the table. y2 minus y1 is negative 7 minus negative 8, over x2 minus x1, which is just 1 minus 0. So when you simplify, you get 1 over 1, which simplifies to 1. If you look at the slope of line F, we have to count the rise over run. To get from one point to the next, I fall 1 and run 1. So I go down 1 and right 1, down 1, right 1. That makes the slope negative 1. And 1 and negative 1 are actually opposite reciprocals. Because 1 over 1, if you switch it upside down, if you make it a reciprocal, is also 1 over 1. So this is the one exception to actually making something look like it's upside down compared to its partner. that 1 over 1 and 1 over 1 are the same thing, so for 1 and negative 1, they're opposite reciprocals, which means the lines are perpendicular. Our last two lines are represented by a graph and by an equation. To calculate the slope from a graph, you just count the rise over run, so pick 2 points on the line and count how far up and down you go, that's the rise, and how far left and right you go, that's the run. So if I pick this point and this point, to get from one to the other, I go down 2, so that's a negative 2 because I fell 2, and then I go to the right 5. So going to the right, that's a positive motion, so I have negative 2 over 5 as my slope for line G. Line H is written in standard form, so in order to calculate the slope, I need to convert it to slope-intercept form. So I'll start out by subtracting 10x from both sides, because my goal is to get y alone. Remember that these two are not like terms, because one has an x, the other one doesn't, so you just have to leave it separate. So I have 4y equals negative 10x plus 32. Then I have to divide everything by 4, and when I reduce that fraction, I get negative 5 halves. Remember that 8 doesn't matter, that's the y-intercept of line H, and that doesn't matter for determining parallel versus perpendicular. The only things that we need to compare are the slopes. And they're reciprocals. 2 over 5 and 5 over 2, those are reciprocals, but they're not opposite because they're both negative. So that means that line G and line H are neither parallel nor perpendicular. Since their slopes are just reciprocals but not opposites, these two lines intersect, but not in any kind of a special way. And that's all you need to know about calculating slope and using it to determine if lines are parallel or perpendicular or neither when graphed in the coordinate plane. And that wraps up Unit 3 on parallel and perpendicular lines. In our next unit, we're going to be exploring the transformations of reflections, rotations, and translations.